Hello everyone, my name is Raina D. Jute and welcome to my Module 10 Concepts video. In this week I was working on the back-end side of things, and unlike last week when I was working on the front end, this week I was inside the server, dealing with routes, controllers, middlewares, and database logic. What I want to do in this video is walk through three concepts I either ran into for the first time, or finally started to understand at a deeper level while working on this project. These aren't just concepts I read about, they're things that I actually had to work with, and in some cases had to spend real time figuring out before they clicked. So the goal here is to show you what I learned, what confused me, and how I understand it now. The three concepts I'm covering are async and await, cascading delete, and Boolean logic and true-the falsy values. So without further ado, let's get into it. Alright, so the first concept is asynchronous JavaScript execution using async await. The classic example of this in this project is a database call. So when your code says go find this user in the database, that doesn't happen instantly. MongoDB has to go look through all of its documents, find the right one, and then send it back. It takes time, maybe just milliseconds, but it's still time. The question is, what does the rest of your code do while it's waiting? And by default, JavaScript doesn't wait. It's what is called asynchronous, meaning it kicks off a task and immediately moves to the next line without pausing for the result, which sounds efficient, but it creates a real problem. If your next line of code needs that database result to work and JavaScript has already moved past it, you end up with undefined values or broken logic. Async await is a modern solution to that problem. If you put await in front of an operation, you're telling JavaScript, pause here, wait for this to finish, and then continue. And when you put async on the function itself, you're telling JavaScript that this function contains awaited operations, so treat it accordingly. Without async await, you would have to use something called callbacks or then chains, which are older ways of handling asynchronous code. They work, but they get hard to read very fast. You end up with code nested inside of more code, which developers often call callback hell. Async await lets you write code that looks like it's running line by line, top to bottom, even though there's still asynchronous behavior happening underneath. It's the same behavior, just much cleaner to read and reason with. So in this project, async await showed up basically everywhere in the backend, because this backend only handles database calls, really. The login flow in session controller is a good example, so let's take a look at that. The controller has to do several things in order. So it has to find the user by email, compare the enter password against the hashed version in the database, then create a new session. Every single one of those steps is an asynchronous operation. So if we take a look, we see this await user find one, await bcrypt compare, and await session create. Each of these lines has to finish before the next one runs, because the result of one feeds into the next. If the find one hasn't found the user yet, it can't compare the password because it doesn't know the password because it doesn't know the user. Password hasn't been confirmed, we can't create a session because we don't know if this user is actually authenticated or not. Async await is what makes sure those steps happen in the right order. The thing that confused me most about this was understanding what waiting actually means when JavaScript is single-threaded, because everything happens so fast. I don't feel like anything is waiting when I'm clicking a button or when I'm making a request on the front end or anything like that. I kept thinking, if JavaScript can only do one thing at a time, how is it waiting for a database and still doing other things? The answer is that await only pauses the function that it's in, not the entire server. So other requests coming in can still be handled. The event loop is still running. It's not like the whole application freezes, just that one function is paused at that line until the awaited promise resolves. The distinction, pausing the function, not the server, is what finally made it click for me. And so now I think of async await like a pause button on a specific function. You're not stopping everything, you're just telling one thing to hold on until it has what it needs. And because async functions always return a promise, everything stays consistent with how JavaScript handles asynchronous behavior. The syntax just makes it easier to work with. So that's all I have for concept number one. Let's move on to concept number two, which is the cascading delete functionality. So the second concept is cascading delete, which is a pattern for making sure that when you delete a record, you also clean up everything that depended on it. A blog post is one of the simplest versions. So in this project, a post can have many comments. Those comments are stored as separate documents in MongoDB, but they each have a post ID field that references the post they belong to. So when you delete a post, what happens to those comment documents? If you don't do anything, they just sit there. The post is gone, but the comments are still in the database pointing to a user ID that no longer exists. That's what's called an orphaned record. It's data that has no valid parent anymore. Cascading delete is the practice of preventing that. So when you delete a parent record, you also delete all of its children, whether that's comments on a post by a user, or whatever the relationship is. In a relational SQL database, you can set up foreign keys that enforce this automatically. The database itself knows about the relationships and can clean up children when a parent is deleted. MongoDB is not an SQL database. It's a document database, and it doesn't enforce relational integrity automatically. The responsibility falls on you, the developer, to build that clean logic yourself in the application layer. This is actually one of the trade-offs of using MongoDB. You get flexibility in your data structure, but you have to be more intentional about managing relationships manually. In this project, I implemented cascade delete in two places. We've got post delete and we've got user delete. For post deletion, it's a two-step process. First, we delete all the comments where the post ID matches the post that's being deleted. So actually, if we take a look at MongoDB, I'll be able to show you a little bit better. So if we take a look really quickly, we can see that posts have a post ID and it's got a user ID attached to it. That's important for the next one. So this post ID, if we look at comments, we see that the comment has a post ID which matches the object ID that's on the actual post. So this is acting like a foreign key in an SQL database. So in this case, the order matters here because we can't delete the post itself because then the comment is sitting there with no post. And if we delete the post first, then that post ID is deleted, meaning that when we go to delete the comments, that post ID doesn't mean anything. It doesn't match anything. So we can't find the comments that were associated with that post, which makes cleanup very tedious. And we can see that again in the code. So we've got this await comment delete menu where the post ID matches the post ID that's in the comment, and then we delete the post. For user deletion, it's a four-step chain, so it's a little bit more complicated. So first, we find all of the comments where the user ID on the comment matches the user ID of the user that we're deleting. So if this user has commented on anything, those comments are deleted first. Then we find all of the posts that were authored by this user. For each of those posts, we delete the associated comments. Then we find all of the posts that were authored by this user. For each of those posts, we delete all of the comments on it first. Then we delete all the posts by the user, and then finally we delete the user. It's a mental model of like a chain reaction. So one deletion triggers another, which triggers another, and that really defines what cascading delete is. It's like the Russian nesting dolls of JavaScript. So the comments live inside the posts, which live inside the user, and so we have to delete the smallest thing first, or else it doesn't work. The hardest part of this wasn't the logic itself, it was the ordering. I kept having to think through, if I delete this first, do I still need this information I need to delete the next thing? And also, what happens if one of the steps fails partway through? That's actually a real limitation in this current implementation. These deletions aren't wrapped in a database transaction, which means if something goes wrong in the middle, say the post gets deleted but then an error happens before all of the comments are cleaned up, I'm left with only a partial cleanup. The comments are still there but the parent post is gone. Understanding that gap wasn't discouraging, it was actually useful. It showed me that data integrity isn't just about writing code that works in a happy path, it's about thinking through what happens when things go wrong mid-operation. So that's all for concept 2. Let's go to concept 3, which is Boolean logic, truly, falsy, and JavaScript operators. This is like 3 concepts in one. And the thing that all of these 3 have in common is that they've been in my code for 10 weeks now, but I've never taken the time to actually sit down and fully understand what they are. I see exclamation points and question marks all over this code, but I never actually understood what was happening, what they stand for, or how to read them. So in JavaScript, every value is either truly or falsy. That means when you use a value inside of a condition, like inside of an if statement, JavaScript will evaluate this as either yes, it passes truly, or no, it doesn't falsy. The falsy values are a specific short list. False, 0, empty string, null, undefined, and NaN or not a number. Everything else is truly. An object with no properties, truly. An empty array, truly. The string false, still truly. And then there are operators that take advantage of this. So like this exclamation point right here, this is the universal not operator. It flips a value to its opposite Boolean. Meaning, if I take this exclamation point out, it says if mongoose type's object ID is valid, which means if the mongoose type object ID is not valid, then we return an error saying invalid ID format. Blew my mind. And then there's also those 2 lines. Yes, and then we've got these 2 lines right here, which lets you provide a fallback if the first value is falsy. And then we have something called optional chaining, which is a question mark and a period. It safely accesses a property without throwing an error if the object doesn't exist. And then we've got question mark and then a colon, which is the ternary operator, which I think was in concepts number 2, which is shorthand for an if-else statement. These small pieces of JavaScript have just kind of slipped by every single week, and I never took the time to truly understand, what is this thing? What is it called? What does it do here? These operators come up constantly, especially in backend code. Validation checks, authentication logic, conditional response shaping, almost everything that involves does this thing exist or not relies on true falsy evaluation. If you don't understand what JavaScript evaluates as truly or falsy, you can write conditions that look right but behave in unexpected ways, like checking if parentheses some value when some value could be the number 0, which is falsy, so the condition fails even though 0 is a valid value. So, wrapping up, those were the 3 concepts I wanted to walk through: async await, cascading delete, and truly and falsy logic. If I had to pick one takeaway from this week, it's that working inside an existing code base forced me to understand things at a deeper level than building from scratch sometimes does. When you build something from scratch, you make choices and you can make them without fully understanding why. You just see the problem and then you execute. You pick a pattern, it works, you move on. But when you step into someone else's code and have to add to it, you have to understand what's already there before you can do anything. Every function you touch, you ask, what does this depend on? What depends on this? And where is it coming from? It's something that I say a lot in my personal life, but being put in the position of a teacher by proxy puts you in the position of a student, because in order to teach something or to do something, you have to first study something and learn it. And so I think this week my understanding of the back end developed much more than it has in any other project, when I could just create it and then move on without having to understand, is this the best way? Is this the most right way? Is this the most efficient way? And so on and so forth. So that's all I have for my concepts video. Thank you for watching, and I will see you on the next one.